Hi there, geometry lovelies. Having a good day? Sure hope so. Here is a warm-up for you to start this video, so go ahead and pause and do it. Okay. So this here is a trig problem. You want to know how I know? Because I want to find a side length in a right triangle. But the information I have is one side length and one angle measure. And that is classic trig. If you want to know a side length in a right triangle, and you have one side and one angle, you are going to use a trig ratio. Now, there's other uses for trig ratios, but that is how we know that that's how we're going to solve this problem, because it's the best way to do it. So when you want to find a side length in a right triangle, and you know you're going to use trig, you're going to need to choose between three trig ratios: the sine, the cosine, and the tangent. The choice is led to by kind of setting up some things in your right triangle. So the first thing to do is to notice that you have an angle, and that angle is 32 degrees, and we call it theta when we're talking about it in terms of variable, but it's labeled 32. That's the angle that we're working with. Directly opposite or across from that 32-degree angle is a side. And we're going to label that side with an O because it is the opposite side. Once you do that, you can go ahead and label your hypotenuse. The hypotenuse is always the one across from the 90-degree angle, so I'm going to label that with an H. And then this other side up here is the adjacent side, and we're going to label it with an A. Labeling our sides helps organize what we need to know in order to pick the correct trig ratio. So now that we have labeled these sides, let's notice what we have and what we want. What we have is the opposite side. We know it's 9 centimeters long. What we want is the length of the hypotenuse, and we really don't care about what's happening with the adjacent side. So now we're going to use that information to choose the correct trig ratio. Again, there are three. There's the sine, the cosine, and the tangent. And we can remember them by remembering so, ca, coa. These little memory devices can help us set up an equation as long as we choose the right one. So the one we choose is going to be dependent on what we have and what we want. We want the trig ratio with this O and the H in it. So that's not going to be the cosine. It's also not going to be the tangent. It's definitely going to be the sine. And so this SOH can help us set up an equation. What that SOH stands for is the sine of the angle is the opposite over the hypotenuse. And so you write it up. The sine of the angle is the opposite over the hypotenuse. And that's how you get your equation. Now, sine of 32 is just a number. I can pick up my calculator, and I can punch in 32 and then press the spin button, and as long as my calculator is in degree mode, I will get 5.5299 and a bunch of other numbers, which I'm going to round to 0.53. Now, if you don't have a calculator or you don't know how to get your calculator into degree mode, you could look this up on a table. The tables are on Google Classroom, and you would go to the table and you would look up the angle 32, and then you'd look to the right and you'd see the sine column, and next to that, you'd see a number pretty close to 0.53, and that's what you're going to use. So then we have 9 over x. Now, the issue is that we have an x in the denominator of a fraction, but don't freak out. Anytime you want to clear a fraction, you just multiply by on both sides by the denominator. So I'm going to multiply by x on this side and by x on that side. And I have 0.53x equals 9, because these guys cancel. That's exactly why we multiplied on both sides with x. So now we're going to divide both sides by 0.53. Boom. X equals 9 divided by 0.53, 16.98. So we know that the hypotenuse, 9x, so we know that the hypotenuse is 16.98 centimeters long. And you're doing trig, y'all. You're doing trig. That's what you're doing. All right, it's time to update your notebook. Why don't you get into that business, get that notebook updated, and then come on back. All right, let's do this. So today, the essential question is, how does right triangle trigonometry apply to the real world? The topic is using trig to solve real-world problems. So trigonometry is very useful out there, and I don't always take a bunch of time to explain where your math lives in the real world, but trigonometry is kind of way out there. People use it all the time. So I've got a lot of great problems that we're going to do to see how our trig lives out there in the real world. But before we get there, let's talk about angles of elevation and angles of depression, because you're going to see those words in the problems that we're going to solve, so I want you to know what they mean. Right triangle trigonometry is often used to find the height of tall objects or how far something is away. This is a very common use for right triangle trig. There's lots of other things you can do with it. But if you want to know how tall a building is, and you don't want to stand at the top of it and drop a huge tape measure down, then you could just stand about, I don't know, 30 feet away from it, use a little bit of trig, and you can figure out how tall that building is. Kind of interesting. Anyway, the first thing you need to know before we start doing stuff like that is the angle of elevation and the angle of depression. So the angle of elevation is this angle here. Notice that it's like this guy's eye, this guy right here. His eye is looking up at that other guy on a box. And his eye, if he was looking straight ahead, would follow along this horizontal. And looking up at this guy, he's looking at an angle that is above that horizontal. That's what the angle of elevation is. It's an angle between the horizontal and a line of sight to some object above. So it's all about looking up. It's the angle that you're looking up at. If you were looking straight ahead, you'd be looking along the horizontal. But the angle of elevation is the angle, the number of degrees that your sight has gone up from that horizontal place. The angle of depression is exactly the same idea, except now you're looking down. This guy over here, standing on the box, if he looked straight ahead, he would be looking along the horizontal. But now he's looking down at this guy down there standing on the ground. What he's looking through is what's called an angle of depression, and that is an angle between the horizontal and a line of sight to some object below. It's all the same, except now you're looking down. Okay? So now that we know angle of depression and angle of elevation, let's solve some real-world trigonometry problems. So this one involves a sailboat and a lighthouse, and this is kind of a safety thing. If you don't want to dash your sailboat on the rocks, you're going to want to know trig. If sailors know trig, they have these maps called charts. And on these charts are all the different lighthouses that are up and down the coast. And one thing that you end up knowing on these charts is the height of a lighthouse. They tell you how tall the lighthouses are. Because from a distance, what a sailor can do is use instrumentation to measure an angle from their boat up to the top of that lighthouse. And they measure that angle, and then they factor in how tall that lighthouse is, this is still a pretty handy thing in case your electronics go out. Sailors know trig so that if their instrumentation goes awry, they can still keep their boat off the rocks. Anyway, it amounts to a right triangle. Do you see this? We've got a right triangle between the lighthouse and the boat, the angle of elevation up to the top of the lighthouse, and then the height of the lighthouse itself is a right triangle. And so we can use right triangle trig. Now what we know is that the angle of elevation measures 16 degrees. That means that all the way over here, the height of that lighthouse is your opposite side. And then the hypotenuse is over here. That's the line of sight from the boat up to the top of the lighthouse. And then this distance, d, from the boat to the lighthouse is your adjacent side. So we've done what we always do. We labeled our sides. And now we're going to pick the correct trig ratio based on what we have and what we want. Well, what we have is the opposite side, the height of the lighthouse, 121 feet. What we want is the distance away from the lighthouse, which is side B, and the adjacent side. And so now we're going to choose the right trig ratio. Well, there's the sine, the cosine, and the tangent. The sine is remembered with so, and then ca for the cosine, and then toa for the tangent. And notice we have the opposite, and we want the adjacent. So these guys are out, and this one's the one to choose. So now we're going to use that to set up our equation, and we got the tangent of the angle is the opposite over the adjacent. The tangent of the angle is the opposite, 121, over the adjacent, d. And we'll solve for d, and we'll see how far away from the lighthouse we are. So tan 16 is, again, just a number, 16 tan, with a computer or calculator in degree mode, you get 0.286, yada, yada. So let's say 0.29. You can also look it up in a trig table, equals 121 over d. Let's multiply both sides by d to clear that fraction. We got 0.29, d equals 121. And then we can divide both sides by 0.29. And d, the distance from the boat to the lighthouse, is 121 divided by 0.29. And that is 41.38 feet. Now that boat knows that they're 41.38 feet away. And so they know how, they're also on those charts are kind of the depths. And so they know pretty much how deep it is where they are and whether or not their boat is safe. So that's one use of trigonometry in the real world. Here's another one. A knight is in distress and is being held captive in a tower. His damsel in shining armor is on the ground below with a ladder. When the damsel stands 15 feet from the base of the tower and looks up at her precious knight, the angle of elevation to his window is 58 degrees. How long does the ladder have to be? So this poor dude is trapped in a tower, and his, a damsel is going to come and rescue him. And so they need to know, how long a ladder do I need here? So let's draw a right triangle to simulate this event. So there's our right angle. That side over here is going to be the tower, and I don't know how tall the tower is. But, let's see, it says a knight is in distress, being held captive in a tower. The damsel on the ground. When the damsel stands 15 feet from the base of the tower. Okay, so if this is the tower, and I don't know how to draw a tower, so I'll do this. If this is the tower, we know that our damsel, the rescuing damsel, is 15 feet away. So that is 15 feet. So it's taking care of this a bit. And then she looks up at her precious knight at the top of the tower, and the angle of elevation is 58 degrees. So we know that that angle is 58 degrees. How long does the ladder have to be? And so essentially what we're trying to find is this. How long does that ladder have to be? So what do we know, and what do we want? Well, we'll have to establish our sides first. Across from the 58-degree angle is the opposite side. Across across from the 90-degree angle is the hypotenuse, leaving this side to be the adjacent. And so it looks like we have the adjacent, and we want the hypotenuse. And so we're going to choose between sine, cosine, and tangent, or so, ha, soa. So we want the one that has the a and the h, because we have the adjacent and we want the hypotenuse. And so it looks like we're going to choose the cosine. These two are not useful. So the cosine, little abbreviation says the cosine of the angle is the adjacent 15 over the hypotenuse x. And now let's solve from here. Cos of 58 is just some button pushing. 58 cos 0.5299, let's say 0.53. 0.53 equals 15 over x. Multiplying both sides by x clears this denominator, and we have 0.53x equals 15. And then we'll divide both sides by 0.53. And we get that the latter should be 15 divided by 0.53. Whoops, that's the wrong. 15 divided by 0.53 is 28.3 feet. Boy, that's a big ladder. I believe in her, though. I think she's going to be able to help them out because she knows Trig, and that's good. So, you know, because of Trig, lives saved. Seriously. All right, here's another one. Now, this is an interesting story from history. According to Chinese legend from the Han Dynasty, General Han Zhen, I think that's how you say that, flew a kite over the palace of his enemy to determine the distance between his troops and the palace. If the general let out 800 meters of string and the kite was flying at a 35-degree angle of elevation, how far away was the palace from General Han Zhen's position? So this is apparently a true story from what I hear, and General Han Zhen used trigonometry to figure out how far away enemies were. So let's draw our right triangle, because that's always the first step. That's going to represent this situation, and then we just kind of have to pull together the pieces. So we've got a kite flying over a palace. So here's our kite up here, and the palace is here. To determine the distance between its troops, so here is the troops and the palace. So we're letting out 800 meters of string. Well, that means that from the troops to the kite is 800 meters, and so we know the hypotenuse. And the kite was flying at a 35-degree angle of elevation. So this is a 35-degree angle. And what we want to know is how far away from the palace are the troops. So we want to know that one right there. All right, now we've got that started. This side over here, across from the 35-degree angle, is our opposite. The hypotenuse is across from the 90-degree, leaving this one the adjacent. And we know that there are going to be 3 trig ratios that we're going to choose based on what we know, which is the hypotenuse, and what we want, which is the adjacent. We have, we have sine, cosine, and tangent. We can remember them with SOA. And now we're going to choose the right one. Well, we have the H, we want the A, H, oh, we're going to use the cosine again. These two are out. And so we have the cosine of the angle is the adjacent over the hypotenuse. Now this setup is a little bit different. In every other situation, that x was on the bottom. This is okay though, this is going to happen. We want to remember that we have to follow the instructions of the trig ratio. The cosine of the angle is the adjacent, which is on top, over the hypotenuse. Regardless of where those pieces lie, you have to follow it just that way. This is actually a slightly easier problem. So let's find out what the cos of 35 is. So 35 cos, 35 cos 0.53. 819.82 equals x over 800. Well, I've been telling you to multiply what's in the denominator every single time, and so just keep doing it, 800. You're going to multiply by 800 on both sides. On this side, these 800s clear. On this side, you have 800 times 0.82, which is 656, and that equals what's left over on the right, which is x. Done. So we know that Hans's troops are 656 meters from the palace. Done. Clever. No. All right, one more just to kind of cement these ideas. So one day after school, you and your friend are walking past Panther Stadium. Your friend says, I'll bet those stadium lights are 100 feet tall. And you say, let's find out. So you and your friend stand at a distance of 30 feet from one of the lights, and you measure the angle of elevation at 64 degrees. Is your friend right? If not, how tall are the lights? So this can be modeled with another right triangle because you've got the lights and the ground and the angle to the top of the lights. And so that is a right triangle. So it says, I'll bet those stadium lights are 100 feet tall. Well, let's see. We're going to find out. We're standing at a distance of 30 feet from one of the lights. So this is 30 feet. And we measure an angle of elevation at 64 degrees. So we can do some trig, right? We have one side length, we have one angle measure, and let's do some trig. So let's label our sides. Across from the 64 is the opposite. Across from the 90 is the hypotenuse. And that side is the adjacent, the one that's left. We want the adjacent. Oh wait, we have the adjacent, and we want the opposite because we're trying to figure out how tall the lights are. So we have sine, cosine, and tangent to choose from. And we remember them from so, ha, soa. And it turns out we have the adjacent and we want the opposite. And that is the tangent ratio because it's the only one that has both of those pieces. So we use that to remember that the tan of the angle is the opposite over the adjacent. Done. Now, yeah, there we go. So again, we're going to be multiplying by that 30 on both sides. You always multiply by what's in the denominator. Sometimes it's a number, sometimes it's a letter, but you use the same path every time. 64 tan of 64 is, oops, I don't think I did that right. 64 tan, 2.05. 2.05 equals x over 30. Now let's multiply both sides by 30. And these cancel, and we get 30 times 2.05 on this side for 61.5 equals x. And so we know that the lights are 61.5 feet. Is your friend right? No. If not, how tall are the lights? 61.5 feet. All right? You can pretty much figure out how far you are away from something or how tall something is by using right triangle trig every single time. So your practice is on quizzes, my dears. It's again not a quiz. I just don't really like the way Big Ideas Math does this stuff, and so I've changed us over to quizzes for a little bit. If you're struggling, please remember that I'm happy to help. I hope you have a wonderful day. Bye.